mini lesson for lesson 2.3. Magic Music, a company that produces new recordings for artists, determined that 4 out of 5 girls will like the new recording artist Sally Pal. If 4,000 girls were surveyed, how many like Sally Pal? So I'm going to set this up. 4 liked out of 5 girls total. So if we have 4,000 girls total, how many will like? I can either do this with means and extremes, or I can scale up. And I can easily see that 4,000, if I divide that by 5, 5 times 800 gives me 4,000. So 4 times 800 gives me 3,200. So I have 3,200 girls will like Sally Pal. In one group of girls, 300 girls liked her. How many girls were in the group? I can set up the same ratio. 4 liked out of 5 girls total. Liked and girls. If 300 girls liked her, they go here. So 300 divided by 4 gets me 75. So 4 times 75 is 300. So 5 times 75 gives me 375. So there would be 375 girls total. Next page, we're going to work on completing the table. So we just found that when there were 4,000 girls total, there were 3,200 that liked her, and when we did 300, we had 375. So I can continue setting up my ratios. For 120, 4 liked out of 5 girls total. So if 120 girls liked her, how many total? So I see that 4 times 30, so 5 times 30 would be 150. I can do the same thing here. If 4 liked out of 5 total, this is the number of total girls, 1,200 total. How many like? So this is times 240 times 240, and I get 960. And then the last one, if 4 like out of 5 total, bring over my labels, and I have 248 who like. 248, 4 times 62. 5 times 62 gives us 310. So I just completed the table to show the number of girls who like Sally Pal and the total number of girls. Question 4 says to determine the ratio between the girls who like her and the total number of girls for each row. Write each ratio in simplest form. So it's the girls who like, so I have 4 over 5, and that is already in simplest form. Here, 3,200 over 4,000. Here's an easy way to start simplifying. These zeros come off. I see 8 goes in here 4 times, and 8 goes in here 5. If I reduce these, I have 300 over 375. I know that 25 goes into here 12 times, I know 25 goes in here, 15. I see 3 goes in here, 4. 3 goes in here, 5. 120 over 150. I get down to the same ratio I had here, so I know this is 4/5. 960 over 1,200. I think by now we can pretty accurately predict that these are going to simplify all the way down to 4/5. So what do we notice about the ratios? I notice that we have 4/5 for each ratio. So in a proportional relationship, the ratio between two values is always the same or constant. That's if we have a proportional relationship. So these 4/5, I got it every single time. If I would not, it would not be a proportional relationship. The ratio is called the constant of proportionality. So 4/5 is called my constant of proportionality. Generally, we can use the variable k to represent the constant of proportionality. So what is the constant of proportionality for the ratio between the number of girls who like Sally Pale and the total number? That ratio is 4/5. Okay, moving on to problem 2. Vista Middle School has determined that 5 out of 7 girls play sports at the school. The constant of proportionality, which k, is 5/7. They want me to write an equation showing the relationship between the number of girls who play sports and the number of girls and the constant of proportionality. So the constant is 5/7. They told me the 5 stands for the girls who play sports. We're calling that S. To the total number of girls, they want me to use T. So I can set this up. Now, if I want to turn this into another equation, I can use my means and extremes and say that 7S is equal to 5T. And they want me to find the number of girls who play sports compared to the total. So I want sports all by itself. If I railroad track this now, I can divide by 7 to both sides, and I will get the girls who play sports equals 5/7 the girls total. So by using my means and extremes in algebra, I can solve. So now it tells me to use the equation to solve. So I'm going to go back to this because I think that's a little bit easier. 5/7 equals S over T. If 175 girls play sports, that goes right here. So 5/7 equals 175 T. They want to know how many total girls are there. So I'm going to figure this out. I'm going to use means and extremes. 7 times 175 equals 5T. So 7 times 175 gives me 1,225 equals 5T. If I isolate my variable, I divide both sides by 5, and I get 245 equals T. So that means there would be 245 total girls if 175 play sports. Now I'm going to do it again. So I'm using what we set up in problem 1, 5/7 equals S over T. Now they tell me there are 287 girls. So that's going right here. How many play sports? That's what I'm going to find out. Means and extremes. 7S equals 5 times 287. 5 times 287. So I get 7S equals 1,435. It's an S, not a 5. If I isolate my variable, I divide both sides by 7. When we divide by 7, we get 205. So that means 205 girls play sports. Okay, we could keep going and do this again. I'm going to go down to 3. They said describe how this first equation is written into the second. So they gave me y over x equals k, and they turned it into where y is alone. So I can do this with means and extremes. X times k equals 1 times y. So right there, I get it. Another way I could do this is y over x equals k. If we want to isolate the variable and get y alone, this right now means divide by x. To get rid of dividing by x, I need to do the opposite. I can multiply this side by x and this side by x. So these cancel off, and I get y equals kx. So 2 different ways. I think means and extremes probably makes a little more sense.